In this section, we're learning about how to use inverse normal distributions on the calculator. And the calculator, the TI-83, has a single function that works with that. And we just need to know how exactly that function works. Now, the general operation here, I'll just kind of write it on screen for you. The general operation of this is that we have the function inverse norm. I'll show you where it is in just a second. It takes one input or up to 3 inputs. So you need to put in probability first, and that has to represent the area underneath the normal distribution curve to the left. So this must be area to the left. And sometimes you're given an area to the right and you have to convert. All right, and then in addition, you can also give it a mean and standard deviation for an original data set, and then it will do some additional computation for you to make the result be relative to some given mean and standard deviation. All right, now where we find this function is under the distributions menu, so we need to press second and the vars key, and that takes you to the distributions menu. And it's probably the third option down. Inverse norm is what we're looking for. Now when you put your cursor next to it and press enter, it will just put the function onto the home screen and it awaits you to input the values of these 3 parameters. All right, now let's see how the function works through an example. So number 1, the SAT scores in a particular year were normally distributed with a mean of 977 and a standard deviation of 85. What score is the lowest you could receive and still place in the top 5% of scores? Okay, well, to answer this, it's always a good idea when you know that you're working with normally distributed data to go ahead and sketch yourself a normal distribution. All right, that visual representation really helps you get a place to begin the problem. All right, we need to know for any normal distribution mean of our population, that's given, and also a standard deviation, which is given. Now, our mean is located right in the center. Then the question is, what score, okay, is the lowest you could receive and still place in the top 5% of scores? All right, so you're not being asked for a probability or a percentage. If that were the case, you would be answering with normal CDF. You're being asked for a value relative to your mean and standard deviation. That's where inverse norm comes into play. Because the top 5%, so this idea here, so out of all these scores inside this curve, the area to the upper end, and I'm just going to block off a small region there and call that the upper 5%. The thing that I'm looking for is this value right here, and that's going to separate the upper 5% from the lower 95%. What I'm looking for, this question mark that I've labeled, is an X value. All right, so it's important that we understand that this horizontal axis is an X-axis. So the value that I'm looking for is on the X-axis, which means I need to use inverse norm to come up with that answer. So the value is going to be inverse norm. The first input is a probability, and it's the area to the left of the value that you're looking for. So if there's 5% to the right of the value that we want, then this region right here, that is 95%. That's to the left. So we have to make sure we change that to 0.95 in this case. Then we give the mean and the standard deviation. So 977 and 85. So let's take a look. 0.95, 977, and 85. That gives me an answer of 1,117 is what we'll go with. So 1,117. Since the mean and standard deviation are to the nearest integer, that's how we'll do the rounding here. Okay, now there's a second question here, which is only slightly different. It's basically the same. But it asks if the ACT scores in a particular year are normally distributed with a mean of 24.5 and a standard deviation of 3.8, what is the minimum score that would place a student in the 73rd percentile? Okay, well, what we can do there is, again, since we know it's normally distributed data, we will draw ourselves a little sketch of a normal distribution. The mean is 24.5 and the standard deviation is 3.8. So I'll just put the mean in the center. Now I want to know what is the minimum score. Okay, so I'm looking for a value relative to the mean and standard deviation, so an x value that is, that would place a student in the 73rd percentile. All right, the 73rd percentile. What that means is a score that is better than 73% of the overall data. So that might be, say, like right here. So if this is the score I'm looking for, then this region to the left is going to make up 73% of all the data available. So to find this missing x value, we will use inverse norm. The first input is 0.73, and notice I didn't subtract that from 1 like the last example. The only time we do that is if the area provided to us is an area to the right of the score that we're interested in. If it's already an area to the left, and percentiles are always area to the left, we don't need to do that transformation. So you pay attention to that. Then we give the mean, 24.5, and the standard deviation of 3.8. Then we'll use the calculator, so second distributions to get to the inverse norm function again, and input our values. So 0.73, 24.5, and 3.8. That gives us our answer of 26.8, and I'm rounding again to match the number of decimals that's available in the mean and standard deviation. And that's how we use the calculator in this section.